All right, so welcome back, my Algebra 1 scholars. So what I'd like to do now is take those basic concepts that we talked about parabolas in vertex form and put them into practice here. We're going to look at three equations of different parabolas, and we're going to identify whether or not each of those graphs would be concave up or concave down. We're going to identify each of their axis of symmetry and the vertex of each one. So let's look at our first example here. F of x equals 1.5 times the quantity x minus 2 squared plus 1. So the first thing that we're going to do in this case is we are going to identify what a is for this particular parabola. And a for this particular parabola is going to be 1.5 because that's that value here out in front of my parentheses. The next value I'm going to look for is h. Now, h is always going to be the opposite of the value being added or subtracted to x in this case. So in this case, it's x minus 2. So I see a minus 2 here inside my parentheses. So h is not going to be a minus or a negative 2. It is going to be a positive 2. And then last but not least, we have k. And k is going to be the value being added or subtracted here outside our parentheses, which in this case will be a 1. So we start by identifying our values for a, h, and k. So the next thing that we're going to do is we're going to determine whether or not this graph is concave up or concave down. And that's going to be determined by whether or not a is a positive or negative number. Now, in this case, a is 1.5. 1.5 is positive, and so therefore we would expect this graph to be concave up. It's going to open upward like a cup, like a smiley face. The next piece of information we can determine about this graph is its axis of symmetry. Remember, the axis of symmetry is the vertical line that passes directly through the vertex of the graph. And it creates a line of reflection or line of symmetry that the graph would perfectly fold upon itself. So that axis of symmetry is always given by x equals h, the vertical line. So our value of h in this case is 2. So our axis of symmetry is going to be x equals 2. And last but not least, we can determine the vertex of our parabola. The x-coordinate of our vertex is going to be the value of h, which is 2. And the y-coordinate of our vertex is going to be the value of k, which is 1. So for this first parabola here, f of x equals 1.5 times the quantity x minus 2 squared plus 1, we determine that the graph should be concave up. It should have the axis of symmetry, x equals 2, and it should have the vertex 2, 1. So let's take a second and look at Desmos here. So I have typed in the parabola that we were just talking about here into Desmos, and this is what the graph looks like. So it does, in fact, look concave up as we expected it to be. If I were to type in here x equals 2 as our axis of symmetry, what you will notice, that vertical line, x equals 2, is in fact the axis of symmetry. It becomes this nice line of reflection for our parabola. And if I were to select the vertex down here, the vertex of the parabola is in fact the point 2, 1. So the conclusions that we made by looking at the formula are exactly describing the characteristics of the graph. So let's take a second and look at another example. So let's consider this second example. F of x equals negative 3 times the quantity x plus 2 squared minus 3. So let's again start by identifying a, h, and k for this particular parabola. A in this case is going to be negative 3 because it's that value being multiplied outside of my parentheses. H is going to be the opposite of the value we see being added or subtracted to x inside the parentheses. So inside the parentheses, I see x plus 2. The opposite of plus 2 or a positive 2 would be a negative 2. So h for this particular parabola will be negative 2. And k is going to be the value of the number being added or subtracted outside of the parentheses, which in this case is going to be negative 3. So I have identified that A is negative 3, H is negative 2, and K is negative 3. So now I'm ready to use those values to draw some conclusions about my graph. In this particular case, A is negative 3. Negative 3 is negative, and therefore my graph is going to be concave down, which is telling me my parabola is going to be shaped like a frown. The next thing that I can determine is the axis of symmetry, that vertical line of reflection. That is going to be determined by x equals h. H for this particular parabola is negative 2, so it's x equals negative 2 is going to be our axis of symmetry. And last but not least, the vertex of this parabola, the coordinates, the x-coordinate should be h, and the y-coordinate should be k. So h is negative 2, and k is negative 3. So the vertex of this parabola should be the point negative 2, negative 3. So let's take a second and see if all of those things that we determined from the parabola, we can see when we look at our graph. So here is a graph of our parabola. Oh, and give me just 1 second here. I'm just making some adjustments so that you can see things a little bit better. All right, so here is our parabola, and it's there here in blue. The first thing that we will notice about this parabola is that it does in fact open down like a frown, as we expected it to. The next thing that we can check here is that the axis of symmetry is in fact x equals negative 2. When I graph the line x equals negative 2, you'll notice it slices the parabola perfectly in half right along that line of symmetry. So our axis of symmetry was correct. And last but not least, I'm going to click here right on the vertex of my parabola, and Desmos tells me the coordinates for the vertex of my parabola are negative 2, negative 3, which was spot on. That's exactly what we determined that it would be using the characteristics of the equation. So another job well done. Let's look at a third and final example here. F of x equals negative 1 times the quantity x minus 2 squared plus 2. So just like with our other examples, we're going to start by identifying A, B, and C. In this case, not A, B, and C, A, H, and K. In this case, A is going to be negative 1 because that number being multiplied in front of the parentheses is a negative 1. To find H, I'm going to look for the opposite of the value that is being added or subtracted to x inside the parentheses. So inside the parentheses for this formula, for this function, is x minus 2. And the opposite of minus or negative 2 would be a positive 2. So h is positive 2. And then k here is going to be positive 2 as well, because k is this number that is being added or subtracted. Sorry, I'm trying to highlight it. I'm just messing it up. The value that's being added or subtracted outside of the parentheses. So now we have determined A, H, and K for our parabola, and now we can use those facts to kind of glean some characteristics. So the first thing we notice is that A is negative, and because A is negative, we can expect our parabola to be concave down like a frown. The next thing that we can use is we can determine that the axis of symmetry is going to be the vertical line x equals h. In this case, h is 2. So our axis of symmetry should be the line x equals 2. And last but not least, we can determine the vertex of our parabola, whose coordinates are going to be h and k. So it's going to be the x-coordinate will be 2, and the y-coordinate will be 2 as well. So let's take a second now and look at these items again in Desmos to see if we can confirm how amazing and brilliant we are. So first thing is, here is our parabola. It's looking good. There, I'm going to make sure it's centered so you can see it. So there's the parabola that we were just analyzing. And the first thing that I noticed right away is that we are absolute rock stars. This graph is in fact concave down, as we expected it to be. The next thing I'd like to notice is that we thought that the axis of symmetry was going to be x equals 2. I'm going to graph my vertical line x equals 2, and not surprisingly, it does in fact become the line of symmetry or the line of reflection for our parabola. And last but not least, we thought that the vertex of the parabola would be the coordinates 2, 2. And when I click on the vertex of this parabola, Desmos does in fact confirm for me that the x and y coordinates of my vertex are both 2. So I hope that this video was helpful. This week we're going to be playing around with parabolas in vertex form, talking about these characteristics, looking at equations that were given to us, creating equations of our own. And so I'm hoping that this is going to start to lay a strong foundation for us to talk about these kinds of parabolas. Hope to see you soon. Keep asking questions and keep up the good work.